going to be DCL-10-65B-3. Number 2 was the failed pellet. And we'll see if that looks a little nicer. Background age you'll see is 5 minutes. That's perfectly fine. So that looks a lot better. We've actually got some resolution of peaks here. We're not at 0% transmittance anywhere in the spectrum. That's a much nicer spectrum to work with, and we've got 50% transmittance here. Still KBR though, so we still have a baseline that's not flat. So I'm going to save this sample, this spectrum. And I always have to migrate to the right folder. And now I can do a baseline correction. That's all water, that chatter. This is all baseline here in the middle. That's probably pretty close to baseline in this one. Just bring that out. Good place. So that's a lot nicer looking. I'm going to use my T to pull this down out of the way. And we'll double click on this. And under comments, we'll write bromination product from reaction of acetanilide with NABR and NaOCl. We have a nice description. I'm going to want to change my display limits. So instead of starting at 55, I'm going to start at 50. It'll give me an extra 5% for the peak labels. And now I'm going to go to find peaks. And I want these peaks here. Right, that's going to give me a lot of peaks over there, but I definitely want all these. I don't know if I want that one or not. 1901. Nothing should be showing up at 1901. So I'm not going to bother with that one. But I'm going to want this 3064. So that looks pretty good. Let's replace. And then I always like to take my little T here and use it to move peaks around so that they're clear. And I might even want a display limit that goes down to like 47 here, so I get a little bit more room to work on the bottom. So I've definitely got a peak at 1604 and 1671. Those are likely carbon-carbon double bond and carbon-oxygen double bond respectively. This is probably the amide, 1671. Amides, because of the resonance form that has the double bond to the nitrogen, have a weaker carbonyl stretch, so you usually see those. This peak at 1115 is probably garbage. It's so small. Same with this peak at 944. I'm going to delete those. And this peak at 565 for the same reason. So. In this region in here, we should be able to see the 835 peak is just a shoulder, so I'm going to delete it as well. So this peak in this region here, we expect to be able to determine the substitution pattern. The NMR will make that even more clear, but we can look in this region and see if we can figure out the substitution pattern on the benzene ring. Right. So we've got a lot of nice peaks that can be combined compared with the literature. I'd like to label these guys, so I'm going to use my T. These were pretty weak, but they're present, and they're in the region for an sp3ch stretch, so I want them labeled. So that looks pretty good. I'm going to save it. Looks like I'm going to try to save it, see if it will. And then I'm going to print that. ECL 1065B3. Let's do a search against the library. And it's a 34.86 mets to 4-bromophenol. So it's obviously not a phenol, it's an analyte derivative. But it is telling that all three of these are 4 substituted. 4-acetaminophenzoic acid, 4-chlorophenol, 4-bromophenol. Maybe we could use that as a little piece of evidence for the substitution. It's not great evidence though, because those match percentages are terrible. And all that really does is prove that the compound of interest isn't in the library. So I'm going to call that DCL 10-65B-3 search. And then I'm going to do the functional group interpretation. And it thinks it's an N-phenyl amide. That's good because it is, in fact, an N-phenyl amide, right? It's an acetanilide. It thinks it's a para-substituted aromatic hydrocarbon. So you see that this peak over here, that peak at around 835, it thinks is evidence of para-substitution. And it thinks it's an aromatic benzoate ester. Well, it's not, but you know, whatever it thinks it is. So we're going to print that. And we're going to save that. As, oops, DCL-65B-3 functional. So we can combine those files later. Don't need to save the changes. I'm going to leave Omnic open because I'll probably be using it again today. And then we just need to take our sample out and clean it up. Push that sample out of there. And I won't make you watch me clean up. We'll just set those in the back to be cleaned up later.